In this tutorial, we will be discussing Avogadro's number. Alright, so here's a little scenario for you. Some hardware stores sell nails by the pound, which is easier than selling them by the nail, because it's easier to weigh out than it is to count individuals. However, customers often need hundreds of nails, and counting them takes too long. A customer still needs to know the number of nails contained in a given weight of the nails, so that way they can figure out how many pounds to buy. This problem is very similar to when you're asking for the mass of an element. So let's take this one step further and actually do the calculation. The hardware store customer buys 2.6 pounds of medium-sized nails, where a dozen nails weighs 0.150 pounds. Alright, so that's going to be our conversion factor. So a dozen nails, which is 12 nails, is equal to 0.150 pounds. How many nails did they buy? So we take the number we're trying to convert over 1, 2.60 pounds over 1. Look at our conversion factor. We have pounds on the top. That means we want to have pounds on the bottom. 0.150. And that comes in 12 nails. So we multiply and divide that out, and it comes out to be 208 nails. So basically what this means is that it's a much easier way for somebody to buy nails. You go in, you weigh out 2.5 nails, 2.6 pounds of nails, and you automatically know you're going to have 208 nails when you walk out, rather than having to sit there and count 208 nails. Well, weighing atoms is the similar situation. We have to use mass. We cannot possibly count atoms individually. So we have to have some way of converting from one to the other. Atoms are entirely too small and too numerous to count individually. We would spend our entire life doing just 1 pound. So with nails, we use a dozen as a convenient number in our conversions. A dozen is still too small for atoms. We need a larger number. So that's where we come up with 6.022 times 10 to the 23rd. That is a mole of atoms. It's just another system of counting. That's all it is. 1 mole of anything is 6.022 times 10 to the 23rd units of that thing. So it's a very general term. This number is called Avogadro's number, named after Amadeo Avogadro. 6.022 times 10 to the 23rd marble is 6.022 times 10 to the 23rd sand grains. It doesn't matter. Those units will change, but the number does not. Once again, think of this as just a typical way of counting. 24 cans in a case, 12 eggs in a dozen, 1,000 pages in a ream, so on and so forth. It's just a generic way of counting. And it just makes the numbers easier to deal with. Instead of counting out each individual atoms, we can now say 22 copper pennies is 1 mole because of their weight. If we look at the weight of helium, we can fill up 2 balloons in 1 mole. Alright, so let's start using these numbers as a calculation. Remember, the number is 6.022 times 10 to the 23rd. I mentioned that this is a generic term. The big question that always comes up in chemistry is, when do I use what number? You're going to use this number when you see one of 4 terms: molecules, atoms, ions, or formula units. If you see one of those 4 terms show up, you're automatically going to use Avogadro's number. So for instance, this one. Convert 3.5 moles of helium to the number of helium atoms. Note the word atoms. Atoms is right here. That means we're going to use this number. That means our conversion factor is going to be 6.022 times 10 to the 23rd atoms is equal to 1 mole. Alright, from here, we're going to put the number we're trying to convert over 1. So 3.5 moles of helium over 1. We have moles on the top. That means we're going to put moles on the bottom. So I'm looking at the conversion factor, and I look for the word mole. The number 1 goes with mole, and it's equal to, and we're going to put this on the top. If you do not know how to put this in the calculator, you need to look for a button that says EE or EXP. A lot of time, it's the second function. The answer comes out to be 3.5 times 6.022 times 10 to the 23rd, which comes out to be 2.11 times 10 to the 24th. If you did not get the correct coefficient here, to the 24th, you did something wrong. You need to figure out what you did wrong, because that's probably just an issue with not using your calculator properly. And if you figured that out, you'll be fine. When you type it in, you should type in 3.5 6.022. Look for the EE button, probably second function EE 23. That's the most common, but each calculator is slightly different. Let's try another one. Convert 1.1 times 10 to the 22nd silver atoms to moles. So we have atoms here. That means I'm going to use 6.022 times 10 to the 23rd. Now we're looking at silver. Silver is in the base unit of atoms. Is equal to 1 mole. That's our conversion factor. 1.1 times 10 to the 22nd. Goes on top over 1. We have atoms on top. That means I want to put atoms on the bottom. Look at our conversion factor. 6.022 goes with that. Times 10 to the 23rd. 1 mole is what it equals to, so it's going to go on top. So it's going to be 1.1 second function EE 22 divided by 6.022 second function EE 23. That comes out to be 0.018 moles of silver. Once again, if you do not have this number, or 0.0180 somewhere around there, 0.19 somewhere around there, you need to figure out how to use your calculator properly. Alright, now we're going to change it up a little bit. Now we have it in molecules. Look at H2O. H2O's base unit is a molecule. So we're okay. We're going to use 6.02 times 10 to the 23rd again, but now we're going to put the word molecule there instead of atoms. Remember, it represents one of those 4 units. At any point in time, you have to ask yourself, is what I'm given the representative unit? And we're going to come up to this type of a question next, after this one. So, put the number we're trying to convert over 1. We have moles on top, which means we want moles on the bottom. Look at your conversion factor. 1 goes with moles. 6.022 times 10 to the 23rd molecules goes on top. So 0.2 times 6.022 second function EE 23 comes out to be 1.20 times 10 to the 23rd molecules. Okay, this next one's going to be a little bit harder. Which contains more atoms? 5 moles of oxygen gas or 5 moles of neon? We're going to do the neon first. It's a little bit easier and you'll see why. So we're looking for atoms. Look at neon. Neon is a single element, so therefore it is already in atoms. So 5.0 moles of neon over 1. In 1 mole of neon, there's 6.022 times 10 to the 23rd atoms of neon. Multiply that out, and it comes out to be 3.0 times 10 to the 24th. That's no different than what we've done so far. Alright, let's look at the oxygen now. This one's a little bit more difficult. 5.0 moles of oxygen over 1. Look at oxygen. Notice that there's a 2 down here. That means the representative particle is no longer an atom. This is now considered a molecule. So, when we put this into our equation, 1 mole of O2, 6.022 times 10 to the 23rd, is no longer atoms. I'm going to use the word molecule here instead. I need to get it over to atoms. In order to do that, I need to look at the molecule and say how many atoms there are. For every 1 molecule, there are 2 atoms. So 5.0 times 6.022, second function 23 times 2. That comes out to be 6.0 times 10 to the 24th atoms of oxygen. So that means 5 moles of O2 has more atoms than 5 moles of neon. We're going to do one more example of this just to make sure you understood this last one. How many ions are in 3.5 moles of FeSO4? You'll notice that FeSO4 has more than 1 atom. So therefore, the representative unit here is the formula unit. I know it's a formula unit because it's an ionic compound, because Fe is a metal, SO4 is a polyatomic anion. So if I were to break this down, iron would be my positive ion, SO4 would be my negative ion, my anion. So 3.5 moles of FeSO4 over 1. In 1 mole of FeSO4, I'm going to get it to formula units first. There's 6.022 times 10 to the 23rd formula units. And then each 1 formula unit, there's 1 iron and 1 sulfate, so I have 2 ions. So 3.5 times 6.022 times 10 to the 23rd times 2 comes out to be 4.2 times 10 to the 24th. And I hope you have a better understanding of Avogadro's number now.